Okay, to start this review off by using a Calc I problem and talking about instantaneous rate of change and what it is, and then we'll move on into all the other review material, all the review material of Calc I for this Calc II class. Instantaneous rate of change, if you have a function and that function is going something like this. If I want the rate of change is nothing but slope. Rate is equal to call. Distance is equal to rate times time. R is equal to D over T. So R is equal to the difference in distance over the difference in time. And that is basically what sets us up as instantaneous rate of change, or rate of change. This is rate of change. If I was to take a red marker and put a dot here and a dot here, basically there is our rate of change. Rate of change is another word for slope. And as we take this line using the limit theorem, if we take this line, this dot right here, and we move it, and move it, and move it, and move it, eventually, the secant line will become the tangent line. I wasn't going to get it to work, but it has something to work with you. It'll get closer and closer and closer, and we will have, instead of the secant line, instead of a secant line, we'll have here we'll have a tangent line. So where the rate of change, or the rate of change, the slope of any 2 points is called the rate of change, the instantaneous rate of change is basically the slope of the tangent line at a single point. Now, another way of showing this, if you remember your Calc I, is blow it up a little bit more. And let's say we've got a line, look at something like that, and we take a point here and a point here, and I want you to write this point in terms of x and y, but don't write x and y, write it in terms of x dx, or x and f of x. So our first point represents x and f of x and y. Second point, you can't put x again because this is not x. X is not equal to x here. So I like to say that this area right here, and I'll highlight it using the yellow highlighter. I'm going to highlight this area right here as h. Some people call it delta x, or delta h, or some people call it x, or delta h. Some people call it h. Some people call it delta x. Whatever you want to call it. I'm going to call it h. I'm going to color it blue. Okay? So this right here, this you can't use x because x cannot equal x here because they're not the same number. So this would be x plus h. So this coordinate right here would be x plus h. So what is this? What is this coordinate right here? Well, if this is x, and this is f of x, this is x plus h, what is this? F of x plus h. So f of x plus h, that's the same as that right there. Alright, now here comes the part where you have to think a little bit. And what I mean by think a little bit, well, a lot of people at this point, they go, okay, I understand that, I understand that. But then when I do the next point, they go, wait a minute, what are you doing? Well, I told you in the slide before this, I told you that slope is rate of change. I think everybody remembers that. So if I want to find the rate of change, I just want to find the rate of change. Anywhere on this line, rate of change. That's going to be equal to your delta t, delta d over your delta t. Well, that's the same thing as your slope. And slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, let's plug in our numbers. What's y sub 2? There's y sub 2 right here. Y sub 2 is f of x plus h minus f of x over x plus h minus x. And that's going to be equal to f of x plus h minus f of x over the x is canceled over h. Now, this is basically your slope for any point on this line, any 2 points on this line. Now, as I tell my calc students, this is your algebra. In other words, this is not using any calculus, this is just 2 points on the line. So if I wanted to find the slope of this line, I'll color it blue. If I wanted to find that slope, all I would do is take this coordinate, which you could call this 2 and 1, and you could call this 4 and 5. And then you would say 5 minus 2. I mean, your y here is 1, 5 minus 1 over 4 minus 2, or whatever the case may be, to find your slope. That's what this is right here. Okay, let me give you an example. Let me erase this. Erase this. Erase this. Erase this. Let's say we have the good old-fashioned numbers here. This is 1, 2, 3, 4, 5. 1, 2, 3. All right, this point is 2 and 1. This point is 5 and 3. All right, so this point is comma, is parentheses 2, comma 1. And this point is 5, comma 3. Now I want to find the slope of this blue line. That would be 5 minus 2 over 3 minus 1, which is equal to 5 minus 2 is 3 over 2. So there's our slope. The only difference is here I put the numbers in, and here I don't have numbers. And that gives you the basic what's called the difference quotient. Now, this guy is very important because this gives you basically your derivative in calculus when you apply the limit theorem. So this is called the difference quotient. And the difference quotient applied with the limit theory will give you your calculus, your derivative. So let's take this guy. Let's go to the next page. F of x plus h minus f of x over h. Now, as we said before, I'm going to go back to this page. Let's say that this guy gets closer and closer and closer and closer and closer, just keeps on going until he gets, he gets here, 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 gets here. What happens? Well, I'm going to take this red line. All right, right here we still got a secant line. 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 What happens when that line, when that point is right about there? Then you have what's called tangent line. Now the tangent line gives us an instantaneous rate of change. Tangent line basically gives us an instantaneous rate of change, which is a little bit different from the rate of change that we got a while ago. The rate of change we got a while ago was a secant line. So any one of those secant lines is basically a rate of change because it's a secant line. But if you get this point real close to the other point right here, you get those 2 points, I'm talking about the half of a pin width. I'm talking about really close. Then the secant line turns into a tangent line, which gives us the instantaneous rate of change, which means at any point on the line. So we have to apply the limit theorem because that point, these 2 points, are getting closer and 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 closer. And we're talking about micrometers beside each other, and that line becomes tangent line. And the way that we do that is we say the limit as h approaches 0. Let's go back. H approaches 0. H approaches 0. It's going this way. As h approaches 0, as this comes down, h approaches 0, and it gets close to 0, but it doesn't touch 0. So h approaches 0, f of x plus h minus f of x over h. And this is called the quotient rule, or the difference quotient with the limit theory, which gives you the instantaneous rate of change. So let's take an example. F of x is equal to x squared plus x minus 3. Now we know this is a parabola. Review a little bit, complete the square. X squared plus 3, x squared plus x plus 0 plus blank is equal to 3 plus blank. Half of 1 is 1/2, 1/2 squared is 1/4, 1/4, x plus 1/2 y squared is equal to 3 plus 1/4, which is equal to, this right here is 12 over 4, which would be 13/4. So we've got a vertex of negative 1/2 and negative 13/4. And that's our vertex. And then x plus 1/2 is equal to the square root of 13 over 2, which is x is equal to the square root of 13 minus 1 over 2. And we know that the square root of 13, we know that 9 is 3, and 4 is 16. So 9 to 16 is 7, half 7 is 3.5. So 12.5 is equal to 3.5. So this is around 3.6. X is equal to 3.6 plus or minus 1 over 2. 3.6 minus 1 is 2.6. Divided by 2 is 1.3. And negative 4.6 is negative 2.3. So there's our two x-intercepts. So we're talking about a parabola that is, the vertex is negative 1/2 and negative 3 and 1/4. So negative 1/2, negative 3 and 1/4 would be down here. And 1.3 would be right in here. And negative 2.3 would be right in here. And y-intercept is negative 3. So that would be 1, 2, 3. Be somewhere right in here. That's what the parabola looks like. So they want to know what is the instantaneous rate of change. So pick a point. Well, let's take this point. This is all algebra. This is stuff you should have learned way back in algebra. So let's pick this point right here. We want to know what is the rate of change there. Well, actually, there's a point up here. And we can get that rate of change, but as they get closer and closer and closer, we want the instantaneous rate of change. So we're talking about a tangent line looking something like that. So, how do you find the equation for that line? Because that's what you want. You want the equation for the slope of the line. So, what do? Well, we use our handy-dandy difference quotient. F of x is equal to x squared plus x minus 3. And we're going to do a limit as h approaches 0 of f of x plus h minus f of x over h. Well, this guy right here says anywhere there's an x up here, I got to plug in x plus h. That's what that means. So, parentheses squared plus parentheses minus 3. That's our function. And wherever there's an x, I'm going to plug in x plus h. Minus f of x, which is this. Over h. Now you got to use your handy-dandy algebra here. Limit as h approaches 0. So here's my handy-dandy shortcut number 1. So that's x squared plus 2xh plus h squared. Plus 2xh plus h squared plus x plus h minus 3 minus x squared plus, minus x plus 3 all over h. Okay, x squareds cancel. Minus x and the plus x cancels. Minus 3 and the plus 3 cancels. I'm going to go to the next page, but basically you're going to have, let me write this up here so I can copy it. You're going to have 2xh plus h squared over, no, plus h, over h. I'm going to copy that. Copy. And we're going to write it over here. Limit as h approaches 0, or x approaches 0, h approaches 0. And that's going to be, I'm going to put it right here. Alright, so we've got to get all our h's out. Limit as just x approaches 0, sorry. X approaches 0. 2 of h, and that's going to give us a 2x plus h plus, factor out h, that'll be a 1 over h, and what happens to the two h's? They go out. And there we go. H, it is H. I'm sorry. It is H. And H goes to 0 here, and that gives you 2x plus 1. Now, what have we found? We have just found the equation for the line. Equation for the slope of the tangent line at any point on the line. You have just found the equation for the slope of the tangent line at any point on the line. So let's go back. We know it's 2x plus 1. Let's go back here. Let's say that this point right here, you know this is negative what? Negative 2.3. Let's go with negative 2. And x is equal to negative 2. X is equal to negative 2 is right here. I want to know the slope of that line right there. I want to know the slope of this black line going right there. That x is equal to negative 2. Well, we'll go over to our handy dandy equation that we got. F of x, well, f prime of x is equal to 2x plus 1. And Rx, f prime of negative 2, is equal to 2 times negative 2 plus 1. And negative 4 plus 1 is equal to negative 3. So the slope of that line is negative 3. Negative 3 over 1. And that would be negative 3 over 1. So you got the negative means left to right down. And let's see, negative would be 3. So it'd be 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. So it looks like a line going down that way. And you can see that that line is pretty, it's significantly like that, negative 3 over 1. Well, why don't we do the one over here at 1? At 1, okay. I guess that would be the one right there. At 1, x is equal to 1. Let's see what happens. F of 1 is equal to 2x plus 1. 2 times 1 plus 1. 2 plus 1. So the slope at that point is 3. Now, basically the difference quotient, as I said to you before, the difference quotient is nothing but algebra. limit theory is calculus. You put those two together, and you basically got the derivative. And that gives you, the derivative will give you the equation for the slope of the tangent line. At any point on a line. So you can either do it by algebra and calculus, or you can use the derivative law. Let's use that same problem. F of x is equal to x squared plus x minus 3. And use that 2 out front. That's going to be f prime of x is equal to 2x, subtract 1, that'd be 1, plus, that's a 1 right there. So your f prime of x is going to be equal to 2x plus 1, in which that's what we got with the difference quotient a while ago. So either you can do all of this right here, plug, shove, do all the algebra, then apply the limit theory and get that. Or you can apply your calculus rules for differentiation and bring the 2 out front, do that, and then you get the same thing. It's kind of like appreciating the calculator for the multiplication tables. You appreciate the calculus when you learn how to do it by hand, by the algebra. So that's one of the first things we want to review for Calc 1, and that's the derivative.